Hello, everyone. Welcome to my talk. And today I'm very excited to talk about Zone.js. So my name is Jia Li, and I'm a software engineer from ThisDot. So if you're using Angular, you may have heard of Zone.js. So I have been contributing to Zone.js about 4 years. So now I'm the co-owner of Zone.js library and also a collaborator of Angular. So today I would like to make a brief introduction about what Zone.js is and why you may need Zone.js. And finally, I would make several demos to show you how Angular works with Zone.js. So Zone.js is a library created by Brian Ford about 6 years ago, I think. And the idea is inspired by the Dart language. So basically, Zone.js provides an execution context that persists across the asynchronous operations. So this is the features that Zone.js provides. It provides an execution context and also a set of lifecycle hooks of the asynchronous tasks and error handler for the asynchronous operations. And about what is the execution context? So in the JavaScript world, execution context is a concept that holds information about the environment within which the current code is being executed. Let's make a very simple JavaScript 101 sample to make some detailed explanation. So here we have a function. And when we execute this function, and there will be an execution context. And we can access the JavaScript keyword this to get the information of the context. And of course, JavaScript provides several ways to run a function. So based on which way you run the function, the JavaScript this, the value of this will change. So this is the JavaScript, how JavaScript VM handle this execution context. So basically, in the JavaScript world, when code is executed in a function, there will be a new execution context. And it will determine the scope of what you can access, and also the value of the keyword this. And execution context will also impact the stack trace. So here we have the function ABC, and in the function C, we throw an error. So in the stack trace, we can see all the stack of the ABC information here. But if you run the similar code with a synchronized operation, such as set timeout, and we throw an error in the callback of this set timeout, we will only find the information about this callback itself. We will lost the information of the timeout, which is the function that schedules this set timeout operation. So this is kind of the missing feature of the execution context of JavaScript. So there is no execution context across functions, especially for the asynchronous operations. So let's see what execution context feature provided by Zone. So here there is a sample code. We run a function inside a Zone. And inside this function, imagine we suddenly has a new execution context. We have a new keyword. Let's just call it zone this. So this zone this will be equal to the zone and inside this function. And not only in in this function itself. And here we have a set timeout. So this execution context provided by zone, this zone this, will still be equal to zone in the callback of this set timeout. So the execution context, this zone this, will be kept in the callback, and it will be equal to the execution context when this asynchronous operation is scheduled here. So not only the set timeout, but the other asynchronous operations such as promise then will behave the same way. So the zone this will also be kept here, and it will be the same when it is being scheduled. So when we run some function inside the zone, and we suddenly have a new zone this execution context that persists across functions and also across the asynchronous operations. So this is the most fundamental features of the of Zone.js. It provides additional execution context. So it looks like we have a new zone list keyword. And for the synchronized operations, it will be the zone it is running in. For the asynchronous operation, it will be the zone it is when it is scheduled. And of course, we didn't really introduce a new JavaScript keyword. So to access this new zone list execution context, you need to call zone.current to get it. And besides the execution context, Zone.js also provides a set of intersectable lifecycle hooks of this asynchronous tasks, so you can monitor and manage and do some logic about these asynchronous tasks. But let's make another JavaScript 101 sample to explain it. So here we have a set timeout. I will use this graph to explain how it works in JavaScript. Maybe you know about it, so I will make it very quick. So here we have a stack. This is JavaScript stack. And web APIs, this will be browser or Node.js VM. And also a macro task queue of the JavaScript VM. So this is the native JavaScript set timeout without Zone.js. So let's see how it works. So first, in the main stack, we have this function call, and we will call the set timeout, and we will send this set timeout request to the browser, and to see, okay, we want to schedule a callback in 1 second. And then this main stack is finished, is done. And after 1 second, the browser will send this callback, send this set timeout task in the macro task queue. And if there is no pending task there, it will move this set timeout callback, set timeout task from this macro task queue to the main stack and run it. So this is basically how set timeout works in the JavaScript, native JavaScript VM. And because set timeout is asynchronous, so the run order will also look like this. So here we have ABCD, and CD is running in set timeout. So the final run order will look like this. So imagine if you want to measure the performance of this for function. And if you write code like this, the performance will not be measured correctly because the CD function will be run later. So it just look like this. So let's see what happens if we run the set timeout, the same code in a zone. So here we have a zone, and we have several lifecycle hooks defined here. Those hooks is the most frequently used lifecycle hooks. And let's take a look how it works. So here we use the same graph to demonstrate the mechanism. So here we have a zone, and so we create a new zone, and we run this set timeout inside this zone. And when we call set timeout inside the zone, instead we directly call the native set timeout, we will call a zone patched version of the set timeout. So it will call the lifecycle hook on scheduled tasks before it really called the native browser set timeout. So basically, it notified the zone. Okay, currently in this zone, there will be a new task being scheduled, so you can do something about it. And in this unscheduled hook, it will call the native set timeout, and to tell, okay, there will be a function being executed in 1 second. And because Zone has an internal task state to manage all the status of the synchronized operations, so before this unscheduled task, it is empty. And now there is a new one coming here, so the macro task count will be 1. So it will become from empty to 1. So this onHasTask lifecycle hooks will also be triggered. And then this set timeout operation is done. And after 1 second, this set timeout will be moved to the macro task queue. This is JavaScript macro task queue. And there is no other pending task, so it will be moved to the stack. And also because this callback is running in the zone, so before this function itself being executed, another lifecycle hook, which is on invoke task, will be executed first. So basically, it will tell zone, okay, there is a callback of a synchronous task will be executed. And okay, and after this on invoke task is executed, the callback here will be really run. So after this task is invoked and it is consumed, so the task is finished. So the zone task state will become from 1 to 0. It become empty again. So the on-has task lifecycle hooks will be triggered again. So basically, this is how Zone.js, how a synchronized operation inside the zone, how it runs, and how it triggered the lifecycle hooks. So let's back to the same use case about the performance measurement. So if we want to measure the ABCD here, we can write some code like this. We run those functions in a zone, and we can use this performance start and end to measure all the synchronized calls. And we can use on invoke task lifecycle hooks to measure the performance of the asynchronous operations, which is C and D here. So the graph will look like this. And there is another very useful lifecycle hook, which is on handle error. So handle the errors inside the asynchronous task is always very difficult. But if you are using Zone, you can all the errors inside the asynchronous operations will be catched by the Zone and triggered on handle error lifecycle hooks. So you can write the error handling logic in a central place, in a single place, which is very useful. So how Zone.js can do that, can implement such kind of features? So basically, Zone.js uses the monkey patch technology. So it monkey patch all the possible asynchronous APIs and add the execution context and lifecycle hooks logic in it. So one way should use Zone. So basically, if you want to monitor or test or do something or to manage about your asynchronous operations, you may want to use Zone.js. For example, you want to test asynchronous operations to debug trees, perform measuring, or do some auto rendering, auto release when all the asynchronous operations are done. You may want to use Zone.js to do that. So I will use some demo to show you the use cases. The first one is the long stack trees. So imagine the code here. We have main function. In this main function, we add event listener to the button 1. And in the event listener, we bind another event listener to button 2. And in here, we throw an error. So imagine we don't have Zone.js. In the error stack traces, you will only see the throw error. The error happens here. But from the business logic perspective, the user may want to know the who is the root cause of this error. So they may want to know all this logic history about this function. So let's see. Let's see a demo of this one. So here, if we use the Zone.js, we have a long stack trees zone. Because Zone.js can track all the information of the asynchronous operations, so it can also keep all this history calling information. So because the add event listener is also an event task inside Zone, so here in the arrow stack trees, we can see all the history information from the very beginning. So in this arrow stack trees, we can see from the logic perspective, it is originally from this main function, and arrow handler, the event listener is added to the button 1, and then here in the button 1 event handler, it added another event handler to button 2, and finally the arrow is 0 here. So we can see the full logic stack traces here. Okay, and another example demo will be the tracking, the counting. So here the code randomly generates a lot of set timeout, and we can count the status of this set timeout. So here we click start, a lot of set timeout is scheduled and invoked, and finally they are finished. So we can also monitor all the status of these async operations. And of course, the use case we discussed earlier about the performance profiling, we can also, for example, we have a button click, and we have several asynchronous operations in there. We can also make the performance measurement of these operations. So this is the demo. So basically, it will print the correct result. And we can also do some result automatically release. So here, for example, if you have some resource and you want to use the resource in several asynchronous tasks. So the requirement is you want to release this resource after all those asynchronous operations are done. So imagine if you don't have something like Zone.js, and you may have to write some logic in the callback of those asynchronous operations and to check whether all tasks are done or not. And maybe you have to also have to handle the error, do the error handling to make sure everything is handled correctly. But with Zone.js, you don't need to do in the specified asynchronous operations. You can write the auto-release logic in the lifecycle hooks, such as the onHas task we demoed earlier. So if all the tasks are done, we can release the file descriptor in the onHas task lifecycle hooks. And we can also track the user action. So for example, here we have a button. Inside the button, we have we send 2 HTTP requests. And so with Zone.js, we can track what users are doing. And for example, the user click a button and send 2 HTTP requests, and what is the URL the user sent, and how much time it costs. So with Zone.js, it can print a lot of useful information. So let's see the demo here. Okay. So the code is look like this. So when we click the button here, it will send 2 HTTP requests. So with Zone, we can print some information look like this. So we can know a button is clicked. And inside this button, and 2 HTTP requests is sent, and the URL is here. And the response, we will get a response from this HTTP request. And for each HTTP request, the performance is also be calculated. And also the button click, the total performance cost of inside this button click event handler will also be calculated here. So we can print a lot of user-friendly information. And we click another button, so another block of information will be displayed here. So with Zone.js, we can track the asynchronous operation status and also the nested asynchronous operation information. And of course, the UI auto rendering, and this is the main feature used by Angular. So here we have, for example, the HTTP request, set timeout, or the synchronized operations. And we want to update some date and want to render on the UI. So let's look at code. Look at the code here. We have update task status, and we want to update some UI. But let's take a look of this event handler here. We send some HTTP requests, run some set timeout, we update date, but we didn't call the update task status in the event listener. But let's take a refresh. But if we click the button, the date is automatically being rendered here, because Zone.js knows when this asynchronous operations finish, and it will automatically render the UI for you. And of course, not only the application code, with Zone.js, it can also make your asynchronous test case easier. So Zone.js provides some utility methods such as Async and the fake async to make your asynchronous test running in the synchronous way. So all those features provided by Zone.js are used in Angular. So Angular has an NGZone, and it will tell Angular when to trigger the change detection. And it also had a sync test, fake sync test to, if you write the Angular test code, you may be familiar with this utility method. And Angular also used the on-handle error lifecycle hooks to make the global error handling. And also in the dev mode, Angular also, you can enable the task tracking zone or the long stack trace zone to get more useful information about what happened inside Angular. And this is the NGZone service provided by the Angular. And at last, I would like to show a project I'm recently doing. So I want to make a monitor zone to get more information, can track, monitor more information inside of Angular, especially about the change detection. So what I want to do is track when change detection is happen, and who is the root cause, who is really triggering the change detection, and also tracking the nested tasks. For example, inside the button event listener, we have some set timeout, some HTTP requests. We want to track such kind of parent-child asynchronous operations. And I also want to automatically calculate the performance of the each asynchronous operations, and also provide some useful API to query those asynchronous information of those asynchronous tasks. So I will use a demo to show those ideas. So here is a very, very simple Angular application. I will show you the code, which is super simple. So basically, it will has a template and have several buttons. And let's see the first two buttons. It is simple click and a nested click. And simple click basically do nothing here. And the on-click will call a set timeout and also schedule, make a HTTP request. So which is super simple Angular application. So here I make a trace window. So okay, I will make my window smaller. Okay, so it will show the a component tree structure here. And when I click the button, so here we'll print some information to tell you, okay, now the change detection is happening, and how many time is cost in this change detection. And it will also tell you which component is rendering. in this change section, and how many time is cost for updating each component. So you can replay this behavior. So you can see in this change section tick, the app component is rendered, hello component is rendered, EC component is rendered, but onPush component is not rendered because it is onPush. The data is not updated. And you can see these three components is rendered twice because in dev mode, Angular will make a second run to check the expression change error. And also, it will tell you the information who is the root cause, who is causing this change detection. So here we can see the information. We can ignore these two macro tasks because basically this is the bootstrap. When you bootstrap a module in Angular, it is a promise then. So basically all the asynchronous operations is scheduled in the promise then. So we can ignore these two. So here we can see the cause of this ticking of this change detection is a button click. And the button, the text is simple click, and the event name is click. And the name of this function is the button click listener inside the app component template. So we can get some useful information to see who is causing this change detection. And we can also print the information, okay, this click task is finished and cost 0.4 millisecond. So let's take a look of this next asynchronous task. So when we click here, it prints the similar information here. So because this next one in this button click, it will have a set timeout. In set timeout, we have a HTTP request. So it will trigger several change detection. So the first change detection is triggered by the button click listener here, which is reasonable. And the second one is triggered by the set timeout. And this set timeout is inside this button click listener. And the third one is triggered by the load. And this load event listener is internal implementation of the HTTP common. So this is also an event listener. So you may wonder because in the application code, no one writes the load event listener, but this is internal implementation inside the HTTP client. And finally, there is an additional the fourth change detection, which is caused by the HTTP request, and which is a macro task of the SHR send, and the URL is here. So for this nested asynchronous task, there will be 4 change detections. So with this monitor zone, you can know how many trigger a change detection in the user actions. You can find out the performance and which components render. And you can also find out, okay, is there any unnecessary change detection there to make sure everything is behaved correctly. And just like the previous demo, we can also print the parent-child task information here and how much time costed in each steps. So there are several other ideas in this monitor zone, such as you can also verify the onPush tick. So if I update some date in the onPush component, you can see this onPush component is also being rendered. And also, you can find out, is there any multiple tick being triggered in one task? So if I click this parent-child div, so the source code look like this. So we have a parent click and a child click, and because of the event bubbling, so one click will cause 2 change detection. So with this multiple zone, we can also print some useful information, such as the one task costs multiple tickings. Do you want to try this zone event classing options, something like that? And it may also help you to handle the expression change error. So I also want to try to print more useful information to tell you where is the cause of this expression changed error happened. So so this is this monitor zone idea is still basically an idea. I'm still not sure it can work for all the cases, but this demo only show you the power of Zone.js and to help you the possibilities, the functionality it can provide to help you to monitor and to get information of the Angular. And also, finally, I don't have much time. I also in this tool, I also make some global debug API to query the information. For example, I want to query is there any set timeout being scheduled in my application? Because there are always in some application you are using some third party library. You don't know who is schedule some set timeout, set interval in my operations. So you can use such kind of find micro task API to find out, okay, which library schedule set timeout, set interval in my application. And you can also find the event task. Sometimes it is very useful if you want to some application add some event listeners such as unload. You can also use such a kind of API to query the information to find out who is adding unload event handler in my application, something like that. So basically, with this monitor zone, you can get a lot of information and monitor a lot of information inside Angular. So this is still idea level. So I want to make sure it can work in most cases. So this is my all my content today. And if you have any questions, please contact me. And thank you for listening to my talk. Thank you.